everyone. I am Marc, Angelo, Salas.
And I am Marc Mutya.
And we are here to tell you about physics.
Physics contributes a lot in our daily life. It touches every aspect of our lives. It involves the study of matter, energy, and their interactions. As such, it is one area of science that cuts across all other subjects. Other sciences are reliant on the concepts and techniques developed through physics.
Other disciplines such as chemistry, agriculture, environmental, and biological sciences use the laws of physics to better understand the nature of their own studies. Physics focuses on the general nature of the natural world, generally through mathematical analysis.
Thermodynamics is a branch of physics that deals with heat, temperature, and work done due to it. Heat is a form of energy that can be transferred from one medium to another. Example is heat transfer. For heat transfer, heat travels from hotter surface to cooler. A great explanation for this is when we are cooking. When we put pan with water or something else in it, on burning stove, the energy in flame of stove touches cold pan. It starts transferring heat to the pan, thus making it hotter.
What comes in your mind when you hear the word wave? See waves? Waves formed in water when you drop a piece of stone in still water? Most of you would have thought of the given and have the physical interpretation of waves as either of the two. Can you think of any other form of wave? Can you think of applications of waves in any other field? Well, you would be surprised to know that waves have a widespread applications in our daily life. The light we see is a wave. The sound we hear is a wave. Every musical instrument works by waves. In fact, waves have applications in almost every field of everyday life. From wireless communication to detecting overspeeding vehicles, from the music of guitar to lasers. Almost every aspect of our everyday life in some way involves waves. So what is a wave? Wave is a transfer of energy from one place to another by oscillation of particles about their mean position. Only energy gets transferred, particles remain on their same position. Depending on the method of propagation, waves can be classified into two parts, mechanical waves and electromagnetic waves. The basic difference between the two waves is that mechanical waves requires a medium to travel while electromagnetic doesn't. Light is an electromagnetic wave while sound is mechanical. Before seeing some applications of waves which we encounter in our life, let us see some common terminology of the waves. Wavelength is the distance between the two adjacent crests or trough. Frequency is the number of waves emitted in a second. Have you ever noticed change in sound of a car while approaching you and while receding? Ever thought of why this happens? This is due to the change in frequency of sound when either the source or the observer is in motion while sound travels. Consider a situation in which you are moving towards a wave. It will take a little less time for a wavelength to reach you in comparison to if you were standing. Hence, the frequency of the sound waves increases. This is the Doppler effect. Doppler effect has a very wide applications. It is used in radars, astronomy, medical, communications, military, and various other purposes.
What are electric circuits? You might have been wondering how charges can continuously flow in a uniform direction through wires without the benefit of these hypothetical sources and destinations. In order for the source and destination seem to work, both would have to have an infinite capacity for charges in order to sustain a continuous flow.
Ohm's law states that the current through a conductor between 2 points is directly proportional to the voltage across the 2 points. Introducing the constant of proportionality, the resistance. One arrives at the usual mathematical equation that describes this relationship. I equals V over R, where I is the current through the conductor in units of amperes. V is the voltage measured across the conductor in units of volts, and R the resistance of the conductor in units of ohms.